Hello viewers, welcome to Codifus. I am Sri Kalishwarar, and in this video we are going to discuss about yet another net physics question from the last December 2025 examination. I hope my screen is visible now. Let me dive into the question paper first. Here you can see this is the question paper. Initially we have solved two of the questions here in the part C. The first two questions which we have solved already, like this emission line of a wavelength 550 nanometer and also a spherical gaseous ball of radius 15 meter. These two questions are already solved and the videos are uploaded in my channel. Today we are going to discuss about these two questions, 48 and 49. A cubic sample of edge length L is maintained at a temperature of 4004 Kelvin. The speed of sound in the material of the sample is 5 into 10 to the power of 3 meter per second. The minimum value of L required to excite the lowest frequency phonon mode is closest to. We have 10 nanometer, 30 nanometer, 20 nanometer and 5 nanometer. We will going to solve this question deeply, and also we will solve the 49th question, which is the find the curve that extremes the functional. This is also one of the most easiest questions. We can easily solve it. Okay, first of all, I hope my screen is visible right now. Okay, I will open the board here once again. Let me zoom in once again, zoom in another time. Okay, first of all we have to write what are the given things which we have got here. Let me write here T is equal to 4004 Kelvin, 4 Kelvin. Let me write this as velocity V is equal to approximately 5 into 10 to the power of 3. Sorry for my crazy handwriting here. Let me look at. Okay, we have to find the L, which we have to find here. L is known as the length. Okay, let me first start with the basic fundamentals of solid state physics. Inside a lattice, I hope you have already learned about lattice, which is the fundamental unit of a crystal. Lattice is a periodic repetitive arrangement of atoms in a crystal. This is the lattice. If there should be some interactions between the atom, so due to these interactions, due to the vibration of the atoms in the lattice, there will be a quantized sound energy will be produced from it. There is a energy will be produced from it. It is typically a acoustic or maybe optical. There is two types of energy can be described here. This quantized energy is known as phonon. Mainly it is an acoustic energy, like it is a sound wave which is generated from the vibration of the crystals. It is not photon. Okay, photon is entirely different. Photon is a light particle. It is a sound, quantized sound wave. It is a sound wave. Okay, it is a sound wave. What do you mean by photon? Which is light, quantized energy of light, which is known as photon. I hope you got a clear view on his thing. Let me move to another page and discuss about the sum here. Zoom in once again. We will zoom in and we will zoom in once again. Okay, let me look at the sum first. There is a formula called lambda max. Okay, lambda max, the maximum frequency should be 2 into length, 2 into L. This is the pre-written form in this. Also, there is a formula for frequency which is known as F minimum, which is equal to V divided by lambda max. Okay, here you can see the relation. F minimum is inversely proportional to lambda max. Okay, V is the velocity of the phonon. Let me solve this. There is another equation for phonon energy, which is known as HF minimum. H is, we already know that this is Planck's constant, and F minimum is known as the frequency of the phonon. Like this would be the frequency, this is the wave. We can find what is the frequency. Like this would be the time frame, this would be 1 second. So the frequency is 1, 2, 3, 4, 5. Number of vibrations per second is frequency. Okay. HF minimum is kb into T. T is temperature. Kb is, we already know, Boltzmann constant. Also we will write the value of kb here, because it is one of the most fascinating constants of physics. 1 into 1.38 into 10 to the power of minus 23 joule per Kelvin. Okay, the unit is way too important when we write constants. So here we all set here. We already know what is the formula for L in here. Not here. I think, yeah. From here also we can find the formula for L. What is L? Lambda max divided by 2. What is lambda max? Here you can find V by F minimum. V by F minimum divided by 2. Okay, divided by 2. What is HF minimum? kBt. So here also we can find out the values what we have to derive here. We already know what is the value for F minimum. So when we substitute all of these values, we finally arrive at a formula. Once again, let me write it in a new page. Zoom in once again. Sorry, zoom in. Let me zoom in once again. Okay, I hope the screen is visible. Okay, the final formula would be L is equal to HV divided by 2 kBt. Okay, the final formula we will arrive at when we like rework all the formulas. Finally we arrive at this point. Okay, we already know from the question itself this velocity is 5 into 10 to the power of 3 meter per second. 5 into 10 to the power of 3 means I will write like this only, 500 meter per second, 5 kilometer per second. Okay, T is equal to 4 Kelvin. Okay, this is 4 Kelvin. What is H actually? H is a fascinating constant, Planck's constant, 6.63 into 10 to the power of minus 34 joule second, joule second, which is the unit. For kb we had already written the value here. This is 1.38, sorry, 1.38 to the power minus 3. Okay. Let me substitute all these values on our formula L. When we substitute all the formulas, we finally arrive at a value of 3 into 10 to the power of minus 8 nano meter, sorry, 10 into 10 to the power minus 8 meter, which is known as 30 nanometer. Okay. Why I just fast forward this question, because we have limited time to explain all of the questions. You can do the calculation by yourself by applying all the values into this formula. Okay, this is the value. When we look at the question paper, option B is the right answer. Okay, let me dive into the question number 49 once again. Blank image. Zoom in. Once again zoom in. Okay. Let me look at the question number 49. Here we have a function dy by dx the whole square plus 12xy whole into dx. We have to find the which is correct, which y value is correct for the boundary conditions. We have to find it. Okay, and this is one of the most simplest things we can do with mathematics. We are going to use Euler Lagrange equation for this calculations. We are using Euler Lagrange equations, which is dou f by dou y. Beforehand we should learn all the formulas and all the basic stuff to attend the net examination or any other examination. We should be so much powerful in the formulas that the thing only help you to get score on this kind of examinations. Okay, this is the formula. Here we have to find the equation itself. We already know in the equation we got a format of let me write the second derivative like this: y dash the whole square plus 12xy. We already know y dash is dy by dx. That we substitute these values here in the equation. Okay, so this value goes for here, this goes for here. Okay, this goes for here. For this value we have to differentiate it once again, because dy dash, okay, dy dash dou y dash, we have to differentiate it once again. Okay, for y, let me consider this as y. We have y dash the whole square. For dou y we will have y double dash into 2y. Sorry, 2y 2y dash. Okay, we will have 2y dash here. For dou f by dou y we will differentiate this term. We will get 12x 2y dash minus 12x. I will rewrite it once again. So we get one second, sorry, zoom in. Let me zoom in once again. So we get 12x dy by dx 2y dash equal to 0. We will rewrite it once again. 2 into this is first derivative. When we differentiate it once again, we will get dx square, which is equal to 0. So when we solve this, this will become this. So we get 6x is equal to the second derivative. So when we resolve it, we will get dy by dx as what we get 3x square. We already know the formula for differentiation, which is nx into n minus 1, which is the differentiation formula. We already know for dy by dx. This is the formula we get. When we apply this again, we get the value y is equal to x cube. When we apply the boundary conditions here, for 1 we get 1, for y is equal to 0, that would be 0. Like if you substitute x is equal to 1, we get 1. If x is equal to 0, we get 0, which satisfies the boundary condition. Okay, that's all for this video. We have successfully solved the 48th and 49th question. First question is from solid state physics, and this question is from mathematical physics. Throughout the different categories, we have solved the questions. On the next classes, we will discuss about the 50th question and other question, and also I will going to upload videos on general physics topics as well. Okay, and in the upcoming videos we will also discuss about the some deep learning techniques and physics informed neural networks. Okay, thank you for watching this video. I am Sri Kali. Thank you very much.